Have you ever wondered what makes up everything around us? From the chair you're sitting on to the device you're reading this on, it all boils down to tiny particles called atoms. Atoms are the fundamental building blocks of matter, so small that millions of them could fit across the width of a human hair. They're the smallest unit of an element that retains the chemical properties of that element. Imagine a world made entirely of Legos. Each Lego brick represents an atom. You can combine these Lego bricks in countless ways to build different structures, just like atoms combine to form the diverse materials we see in our universe. From the simplest elements like hydrogen to complex molecules like DNA, it all starts with the humble atom. Understanding atoms is key to unlocking the secrets of the universe. By studying atoms, scientists can learn about the properties of materials, how they interact with each other, and even how to create new materials with amazing properties. So, let's dive into the fascinating world of atoms and explore the mysteries they hold. Now that we know atoms are the building blocks of matter, let's take a closer look inside these tiny particles. At the heart of every atom lies a nucleus, a dense region composed of two types of subatomic particles, protons and neutrons. Protons carry a positive electrical charge while neutrons have no charge, hence the name neutron. Together, protons and neutrons make up the atom's mass. Orbiting the nucleus are even tinier particles called electrons. Electrons carry a negative electrical charge and are constantly in motion, whizzing around the nucleus at incredibly high speeds. The number of protons in an atom's nucleus determines its atomic number, which defines the element to which the atom belongs. For example, all carbon atoms have 6 protons, while all oxygen atoms have 8. The arrangement of electrons around the nucleus determines how atoms interact with each other. Electrons occupy specific energy levels or shells around the nucleus. Atoms strive to have a full outermost shell of electrons, which makes them more stable. This drive for stability is what leads atoms to form bonds with each other, creating molecules and the amazing diversity of materials we see in the world. The way atoms arrange themselves plays a crucial role in determining the properties of a material. Think of it like building with Legos again. If you arrange the Legos in a neat, organized pattern, you get a strong, rigid structure. But if you just pile them up randomly, the structure will be weak and easily toppled. In metals, atoms are tightly packed together in a regular repeating pattern called a crystal lattice. This ordered arrangement gives metals their strength, ductility, the ability to be stretched into wires, and malleability, the ability to be hammered into thin sheets. The type of crystal lattice can also influence a metal's properties. For example, iron can exist in 2 different crystal structures: body-centered cubic, BCC, and face-centered cubic, FCC. BCC iron is strong but brittle, while FCC iron is more ductile. On the other hand, polymers, which are large molecules made up of repeating units, have a more disordered structure. The long chains of atoms in polymers can be tangled and intertwined, giving these materials their flexibility and elasticity. The properties of a polymer can be further modified by changing the length of the polymer chains, the types of atoms in the chains, and the degree of cross-linking between chains. What holds atoms together to form materials? The answer lies in chemical bonding. There are 3 main types: ionic, covalent, and metallic. Ionic bonds form when one atom donates an electron to another. This creates ions with net electrical charges. Oppositely charged ions attract, forming strong ionic bonds. Covalent bonds involve sharing electrons. Covalent bonds can be very strong, as in diamond. Metallic bonds have delocalized electrons free to move. This gives metals high conductivity and malleability. Understanding chemical bonding explains material properties.